Chapter 11, Section 2, Day 2 is more on probability, and today we'll talk about theoretical probability. Just a quick recall from the last stuff we did. A sample space is a set of all possible outcomes, so everything collected together is called the sample space. If everything in the sample space has the same chance of occurring, we call it equally likely outcomes. So some examples of equally likely outcomes are rolling a die, or flipping a coin, or drawing a card from a standard deck of 52 cards. Theoretical probability is found by taking the favorable over the total, just like we talked about in experimental. Take a look at example 1. What is the theoretical probability of each event? Letter A is getting a 5 on one roll of a standard number cube. That means I'm looking for the 5s over the total. Well, on a standard number cube, there are 6 numbers total. Only one of them is a 5, so it's 1 over 6. Letter B, getting an odd number. I'm looking for odds over total. Just in case you need it, here are the possible outcomes on a standard number cube. And of those possible outcomes, the odds are 1, 3, and 5. So there are 3 of them, 6 total numbers. Reduced means I have a 1/2 chance of it occurring. Letter C, getting a number less than 5. That means I want less than 5s on the top, total on the bottom. There are 4 numbers less than 5. Out of 6 total, gives me a probability of 2/3. In letter D, we talk about getting a sum. So the chart to the right-hand side is the sum of possible outcomes, meaning if I roll a 1 and a 1, my sum would be a 2, and so on. In this chart, these are your possible outcomes. There are 36 of them total. This chart is useful to reference. They want a sum of 5. So what I'm looking for is those sums that are 5. That's 1, 2, 3, 4 of them. So that's 4 over 36, which reduces to 1 over 9. Letter E, getting a sum that is an odd number. So I'm looking for odds over total. So odds, those are odds, these are odds, 7s, 9s, and 11s. If you add all of those up, there are 18 of them and still 36 total, which gives you a probability of 1/2. Letter F, getting a sum less than 7. So I want less than 7s on the top, totals on the bottom. Less than 7s do not include 7. 3, 6, 10, 15 of them. So there are 15 numbers less than 7 out of 36 total, reduces to 5 over 12. A deck of cards is also something that is equally likely. So in letter A, they want the probability of a red card. That means reds over total. In a standard deck of cards, there are 26 red cards, 52 total, which gives me a probability of 1/2. Letter B, they want the probability of an ace. That means ace over total. There are only 4 aces in the deck of 52 cards, which reduces to 1 over 13. Letter C, the probability of a king of hearts. That means I want the king of hearts on the top and total on the bottom. There's only 1 card that is the king of hearts out of 52 total. Makes for a rather small probability. Letter D. Letter D, I want diamonds over total. There are 13 diamonds, 52 total cards, reduces to 1/4. Letter E, probability of a joker, means I want jokers over total, but there are none. There are no jokers in a standard deck, which means that the probability of me choosing one would be 0. Letter F, probability of a not spade, which means not spades on the top, total on the bottom, still out of 52. If 13 of the cards are spades, then 39 of them are not spades, which means that I have a 3/4 chance of picking a card that is not a spade. Number 3, the weather forecaster predicts a 20% chance of rain. What is the theoretical probability that it will not rain? Well, overall, probability is out of 100%. So 20% says it will rain, then that would mean that 80% says it won't. I subtract. 100% minus 20% is 80%. Number 4, the theoretical probability of randomly choosing the letter S from the letters in stars. So I want S's over totals. There are 2 S's, 5 numbers total, or 5 letters total, sorry, which makes a probability of 2 over 5.